Now that we have started getting comfortable with the Omnet++ environment, we know that there are C++ files, there are NAD files, and there is any file. It is about time to start looking at the concluding part of the simulation. That is, we want to compile and run the simulation program. In order to compile and run the simulation program, it becomes important to build the simulation programs. Here in this module, we shall discuss what is the build process, how to build, and how Omnet simulations actually realize this building process. Let's look at an end-to-end process. Here, on the left-hand side, you see the raw or the core classes, which are C++ source, the simulation kernel, and the user interface libraries. Remember, the environment, the command environment, and the TK environment libraries. The support that we were getting for queuing, for random number generation, etc. And then, so far, never discussed, but we'll discuss it in due course, the message files, which are the containers for carrying data between gates using the links. So all these have to be grouped together and converted into binary to make it runnable. So compiling and linking of all these is going to take place, and then the simulation program is also going to take the NAD and the Omnet files to eventually run the simulation and give out the results. So the process of building is not very much different from the building process in C and C++ codes. All C++ sources have to be compiled into respective object files. And then these object files are linked to necessary libraries to either get an executable or a shared library, or as we say, a DLL. In order to build the project that comprises so many kinds of files, we need to have support of the graphical user interface project builder. When we build the project, the first time it takes relatively longer because it identifies all the classes, functions, methods, variables, and macros, which cause dependency in the generated makefile. So, using the graphical interface, we can successfully build the project with ease. Just to get more into exactly how build works, let's look at how the command-based using MingW environment builds the project. Once you have the source files and you are in that particular directory where these files are placed, running the op_make command generates a file called makefile. Makefile is actually a record of all the files that need to be linked up together to realize the executable. After running the command make, the project is actually now ready as it gets built and it's suitable for execution. If we look back at the figure again, we shall see that we are almost done with the NAD part, the ini file exploration, and how to build. Now it is appropriate that we look at how the programs, simulation programs, are run and how the results are analyzed.